morning, folks. Getting to the end of the week. I'm impressed we have this many people, and are you all awake?
No.
So, Dave and I and Neil and Matt kicked off VLAND about 18 months ago
18
now.
months, yeah.
Do you want to move on? To essentially be an automated cable monkey. We had a problem in the Lava Lab with lots and lots of tests particularly for the Linaro networking group, needing people to be forever changing cables around. Previously in the lab, no one had really cared that much about networking. It's a machine either has a network connection or it doesn't. In the networking group, we started demanding a lot more.
Yes.
And after a few months of people frantically pestering Dave and Matt to, please will you swap round the cables to this new layout, and then waiting a couple of weeks because, hell, there's plenty of other stuff to do in a lab too, we decided we needed to improve that situation. So we came up with VLAND. It's a reasonably simple concept. We control the switches to set up ad hoc VLANs. We have protected ports on the switches. These are ports that will not be touched by VLAND under any circumstances, just to make sure that if you've got, say, your PDU or your servers on those same switches, you can't end up disconnecting yourself, or losing access to the bits that are really important. It works across switches. We have currently drivers for 4 different switch families. It's reasonably generic in its design, and those 4 drivers are now, I think, a reasonable proof of that. There's 2 Cisco's, there's a TP-Link and a Netgear switch. And we've now made 4 releases. Version 0.4 was released literally less than 24 hours ago. From my room yesterday. Hopefully it works. And if you want to come along literally straight after this talk, Neil and I, if we can get the demo set up in time, we'll be demoing this. So I said, we have 4 different switches supported. We do port-based VLANs. We don't do anything clever like MAC address base or anything yet. It's a feature that is on the to-do list. We now have really, really simple visualization. We don't have a diagram here. Again, I've got to save something for the demo. Plus, equally, when we generated these slides about 3 weeks ago, we didn't have visualization, so I couldn't show it you then. It's basically ready for packaging and shipping in distros. We haven't been there previously. I'm expecting to get Debian packages out in the next couple of weeks. So, we're finally in production. I'll let Dave talk through this.
Yeah, so we have to test this in a real environment. Steve's been testing it in a very isolated rack with 4 various switches, just soak testing it, and it seemed to be robust and reliable enough. So we took the opportunity, because we were creating the LNG micro instance. I should explain, all of LNG's devices were previously in the main Lava production, validation.linaro.org. And this produced some interesting challenges at times, because fairly obviously, if you're the networking group, you're going to be doing things with the network. And some of those things might be disruptive to the lab, and some of those things were disruptive to the lab, like rogue DHCP servers firing up, and suddenly devices getting addresses that aren't in the lab range, and all that sort of stuff. So we isolated the whole of the LNG rack is now in its completely on its own network, on its own subnet within the lab. It has its own external IP address. Sorry for using up one of the last IPv4s. And the rack itself now has, is it, how many switches are in there? 4, 3? 3. We've got a picture in there. But, so there are 3 switches. VLAND D is deployed on there. It's not currently being used, but it's about to be. And as Steve said earlier, the problem we had before was we'd get this diagram from somebody who wanted to run a particular test involving certain devices, multiple interfaces on certain devices, and that meant we had to link one device to another, this device to that device, and also we had to document the MAC address of each of those ports so we knew all sorts of details about how they come up. Now, all of the ports on all of the devices go into the switches, and they can just be put onto these ad hoc VLANs. There were other problems which we outlined at the last Connect, and well, in fact the last 2 times we presented this. We have some devices, they're dev kits, they're not always perfect, it's putting it mildly, that do things like they'll have 2 Ethernet interfaces with the same MAC address. And to get around this, the VLAND D also supports, so you've got a base VLAN. You can actually have one of those Ethernet ports on the normal VLAN 1, and the other one is permanently on a different VLAN. So it they never interfere with each other. We can talk uniquely through those ports. As I said here, there's a lot of hand-holding needed, not fully plumbed in, but we're getting there. We will be there soon. So to give you a quick view of the VLAN D rack, so on the left you can see all the devices. In the middle, just a shot from below. In the back was the actual switches and all the cabling. It was an interesting few days, wasn't it? That involved 4 of us at pretty much full time. So that was Luca, Ed, Steve, and myself. But it's all there, it's all documented, because that's the other thing. To set the VLAN daemon up, you have to document which switch, which port is associated with which Ethernet port on which device. And some of these devices, like some of the x86s, which we use as traffic generators, have got 6 Ethernet ports on them.
9.
9. Oh yeah, sorry, yeah, you're right. Yeah, so, and there's a 10 gig switch in there. In fact, there's the Catalyst 10 gig switch, which has got 2 10 gig ports, and then we've got a 24 port 10 gig switch. So we can now support 10 gig in the lab, or in the LNG micro instance. And so the next thing was, it's all very well. At the moment, we can manually, tapping keys on a keyboard, set up a VLAN, an ad hoc VLAN, or multiple VLANs, so that a test can be run without having to actually go in there and be a cable monkey.
Yeah. So that's a major win. Instead of somebody spending maybe half a day groveling in the back of the rack, it can now be done in 5 minutes with someone logged in remotely. So we could potentially, if we trust people, let them log in, from outside the lab and do it, and it should all just work.
So the problem there, it's still a manual process.
It's still easy to screw up and break the network.
To get it wrong. So there's also there's been a parallel initiative, which is to provide commands within the JSON job control in Lava that allow you to specify the creation of a VLAN and the device ports which are to be connected to that VLAN, and Lava will do that for you.
Yeah.
Set it all up. And there is, as Steve mentioned earlier, there is a demo pretty much straight after this of that, including the visualizations and the rest of it.
So Neil basically has the initial integration work done with Lava. It's not yet in a production release. It's on a branch. It's going to get reviewed literally next week. But hopefully, fingers crossed and toes crossed and everything, we will be able to demo with multiple devices, multiple switches, and visualization all in one go shortly afterwards. So, future plans. As always, we will need to add support for more switches. So far, this has literally just been driven by the switches that we have in the lab. So that started off as a couple of families of Cisco switches. We then, when we started shopping around for switches with lots of 10 gig ports, we looked at the prices for the Cisco ones, and Oh, we winced.
Well, I think more importantly, Rob Booth winced.
Yes. So that's why we found this 24-port Netgear switch, which actually works reasonably well and was much cheaper. I'm sure there will be demands for other 40 gig, even 100 gig switches in the near future. Because after all, especially in LNG, the whole point is we're developing the next generation of switch software APIs, or software APIs that will become switches and, next-gen interfaces. So we've got to be able to support those in the lab. We still have usability issues, nothing major. It's just, so far, the only person who's really been people who've been pushing this on me and Dave. As other people start playing with this, we guarantee they're going to say, oh my God, why have you done it that way? I'm sure I hope we'll get some feedback.
Yeah, to be fair, the architecture of the VLAND means that you can write, in effect, isolated drivers because there's an API. So once you know how to talk to your switch in whatever way you want, you can then hook that into VLAN daemon. So it's flexible enough, I think. But if anybody's got any comments on it, if anybody looks at the code and goes, well, guys, you could have done this, you could have done that. We think we thought of everything, but we probably haven't.
Sure. At the moment, things are resolutely single-threaded because that was so much easier for initial development. So if you want to set up something across a network of 100 switches or something, it's going to be dog slow. That's not been an issue for us yet. Other people may have problems. Again, it's on the roadmap to change some of that as we get there. And we're hoping to see more users. At the moment, I'm not aware of anybody else using this code. So far, to be honest, it's not really been ready for other people to use, but that should be changing soon.
And so the other thing is when we first started talking about this, of course, the first thing we did was try and go and find out if there was anything out there already, and there wasn't. And I think it was Leif who said it at some point. You said, "Oh, is there something we could do this with?" And Leif said, "No, but if you get one, I'll bite your arm off for it."
Yeah, we've heard from a number of other people have all said this sounds like a really useful project for them. We hope they were being honest and not just trying to encourage us because they were not being nice and friendly. We'll find out. So, we have code. It's in Git. There it is. Please play with it. Let us know. Anders told me earlier in the week that he had patches, but hadn't bothered sending them in, and then I'd moved on, so his patches don't apply anymore. Well, push them upstream. Any comments and questions? That was a really, really short talk, but to be honest, we don't have a massive amount to say right now, but we'd love to hear more ideas, more suggestions on what we should be doing. If you think we're doing something totally stupid, equally tell us. It would be nice if you told us a year ago, but we'll take it now too.
I have two questions. Where does this VLAND code run? Inside the network in any of the machines or a dedicated machine inside the network?
It's a fairly simple Python daemon for them. We're going to be sticking it on the master server on the master dispatcher in each Lava instance. Obviously it needs to be on something connected to the switches. That's about the only thing.
Okay. So the second thing is how does the interface look like? It's all command line interface. If I want to establish a VLAN with say port 1, 3, 5, all those things, right? So I put those in the command line interface. That's how it works.
There is an internal JSON API, which is how we expect people to be driving this. That's how Lava does it. We have our own admin tool, which provides the command line, and that talks that same JSON API internally. So
I can supply a config file kind of in order to establish a VLAN. So it'll be a JSON file which I can supply to the VLAND, and then it just sets it up for me.
Essentially, yes.
Okay.
Anybody else? Oh, God. You were involved in the design. You criticise it now.
Yeah, it was terrible from the beginning. So, because I've totally forgotten a lot of it, I've just wondered about a use case that the Lava guys have asked me to try and consider how they could test Pixie booting, right? And the initial thought that came to my mind was VLAND might help me out here, because obviously you Pixie boot from a DHCP server passing you arguments back. Can't be running more than one DHCP server on LAN, although I know LNG love to. So I think VLAND can help me out here. However, I just, as a use case, couldn't quite work it out in my head how you're going to do it, because you'd have to have some DHCP server in the lab that you have VLAND off from everything, and then there's one device you fire up, you stick it in the same VLAN so it can do its Pixie stuff, and then you remove it again. So I think you might have to have another dedicated DHCP server somewhere, but I think with the right poking, VLAND could protect the lab from it.
Maybe. I mean, to be honest, for that setup, could you not just have your DHCP server know the MAC addresses that are involved, and then it'll only give that information to the right machine?
The problem is you have to poke the config, right? You are, oh, a new device, I want to try and, but we don't want to go touching the config on the one DHCP server in the lab, is what I mean. Lava's going to have to change the config on the DHCP server.
Sure.
Then
so
boot the board.
I was talking to Tyler about this earlier in the week as well. Obviously, it's similar conversation. I hadn't sussed, of course, yes, it's the different DHCP server is the problem. Dave, do you want to touch? Screen's gone off. And we were talking about the TFTP server, and I thought, oh, that's easily separatable, of course, and it is. The difficult bit is the DHCP server. Yes, absolutely, you could do this, but then you'd basically need to have a separate server or a separate interface with the DHCP server running on. And absolutely, we could do that. You just need to make sure that your central server then has lots and lots of different interfaces. So you can explicitly have the DHCP server only listening on one particular interface, move that interface off onto a safe VLAN. Yeah, that's doable.
Yeah, I thought it was doable. It was just, I'm pretty sure it can be done.
Yeah, that works.
Cool.
Anybody else? Well, we must be doing the right thing.
Apparently so. Yay. Does this sound interesting and useful to people?
Yeah.
Good. We're getting nods.
Yeah.
Awesome.
I like nods.
So please have a look at the code, play with it. It's now at the point where it's really worth using and playing with. Admittedly, the biggest thing you're likely to hit is the limited device support, limited switch support. The APIs the API that you need to support for a new switch is really, really simple. It's fairly obvious. In fact, I'm going to be plumbing in. We literally got this far, and then Neil just mentioned earlier in the week, you know what, it would be really nice if we had a dummy driver where we could just put something in for testing. And we honestly hadn't thought of that, so that's going to be going in very shortly. If you do need any help, advice, if you're interested, if you want to talk to us anymore, we're around for the rest of the day, obviously, and you know where we are. Mail us, talk to us on IRC, and let us know if you find anything, or if you. Oh, Luca wants to talk to us.
About you mentioned that basically you have tested this with 4 switches so far. We're talking about real hardware, right? Yeah. I was wondering, since also we have heard probably during keynotes about virtual networks, software-defined networks, so on, which are going to be, more and more used probably in the industry. I was wondering if there are plans, and which may be for things like Open vSwitch and so on to be managed.
Thank you for reminding me. That was something I was going to talk about and forgot. Yes, the next driver targeted is an Open vSwitch interface. We had a suggestion that we should be demoing this running on top of Open vSwitch, running on top of ODP. And that will be a really nice thing to show as well. Oh my God, it's turtles all the way down, that kind of thing. Definitely, this can work that way. I mean, most people in the field, of course, are not necessarily going to care about running VLAND, but yes, we definitely should be looking at that too.
Anybody else? Or are we wrapped up?
Cool.
A motion to adjourn, I think.
I think. Thanks very much for coming, guys.
Thank you.